Hello everyone. With the continuation of the last class, I will take the next topic, the applications of maxima and minima. So directly I will go to the problems. The first problem, the temperature T at any point x, y, z, the three variables in space is T equals 400 x, y, z square. Find the highest temperature at the surface of the unit sphere x square plus y square plus z square equals 1. So here they asked to find the highest temperature of the surface, that is the maximum temperature, using the condition. Here, since given the condition, we have to use the Lagrange's multiplier with one subsidiary condition. First, as usual, you have to construct the function f using the condition x square plus y square plus z square equal to 0. Then form fx equals 0, that is differentiate the given function with respect to x, with respect to y and with respect to z. Then equate to 0 and solve that. You will get the stationary values. Then substitute the stationary values to the given function 400 x, y, z square. You will get the highest temperature or the maximum temperature at the surface of the unit sphere x square plus y square plus z square equal to 1. So I will write this step by step. The first one, I take this part, I construct the function, let f equals, the given the function that is t is 400 x, y, z square using the condition plus lambda times of, the condition is x square plus y square plus z square. Except the constant, you have to write the function. Next, form the equations fx equals 0, fy equals 0 and fz equals 0. That is, you have to take the differentiation first with respect to x, then equate to 0, with respect to y and with respect to z, then equate to 0. The first one with respect to x, fx equals, keeping the y and z term constant, the x differentiation is 1, you will get the 400 yz square plus lambda is a constant, keep it as it is, x square differentiation 2x, y differentiation 0 and z differentiation 0. Then you have to equate this term to 0. Similarly, take the differentiation with respect to y, fy equals, with respect to y, the y differentiation is 1, we will get the 400 x z square plus lambda times of, here the x square differentiation is 0, y square is 2y and the z square differentiation 0. You have to equate this term to 0. Similarly, you differentiate with respect to z equals, since the z square differentiation is 2z, multiply with 400, you will get the 800 xyz plus lambda times of x square differentiation 0, y square differentiation 0, z square differentiation 2z, then equate this term to 0. Then solve this, you will get the stationary points. Solve this, then equate the lambda values, you will get the stationary points. So the first one, the first equation can be written as 400 yz square plus 2x of lambda equals 0. Similarly, the second part, 400 xz square plus 2y of lambda equals 0. The third one, 800 xyz plus 2z of lambda equals 0. So using the first one, you can also write the 2x of lambda equals minus 400 yz square, or lambda equals, cancel this, you will get the minus 200 yz square divided by x. This is the first lambda. Similarly, the second one, it is lambda equals minus 200 xz square divided by y. This is the second value. The third one, it is lambda equals minus 400 xy z divided by z. Z also get cancelled. The lambda is minus 400 xy. Next, you equate all the lambda values. Equating the values of lambda, we get the first one minus 200 yz square divided by x. Second part minus 200 xz square divided by y. The third one minus 400 xy. Then equate the first and second part, then second and last one, or the third one and the first one. You will get the points. So the first one, equate these two. This implies minus 200 yz square divided by x. This equals minus 200 xz square divided by y. Then cancel the z square along with minus 200. Cross multiply this. You will get the x square equals to y square, or x equals plus or minus y. So I take only the positive term since I have to write the maximum or the highest temperature. X equal to y. Similarly, equate the second and the last term minus 200 xz square divided by y minus 400 xy. Then cancel this 2 times and x also get cancelled. You will get the z square equals 2 into y square. This implies z equals root 2 into y, or you can also write root 2 into x, since x equal to y you got from the first expression, x equal to y. Then consider the condition of the sphere, x square plus y square plus z square equal to 1. Then substitute in terms of x, you will get the stationary values. Next, I consider the condition x square plus y square plus z square equal to 1. Keep the x square as it is. For the y square, since the y equal to x, you substitute the x. Next, z equal to root 2 into x. So it is root 2x whole square equal to 1. So using this, you can also write x square plus x square, square root get cancelled. 2x square equals to 1. This implies x square equals 1 divided by 4, or x equals plus or minus 2. I take the positive term, x equals 1 by 2. Since the y equal to x and x equals 1 by 2, y you also get 1 by 2. Next is z, you written the z as root 2 into x. So z equals 1 by root 2. 1 by 2 can be written as root 2 into root 2. So we will get the z is 1 by root 2. And they asked to find the highest temperature at the surface of the sphere. So I consider the term using the condition. Therefore, the highest or maximum temperature at the surface of the sphere is t equals 400 xy z square. Substitute x, y and z values, that is 1 by 2, 1 by 2 and 1 by root 2. So you will get the t equals 400 1 by 2, 1 by 2, 1 by root 2 whole square. So it is 50. Therefore the maximum or highest temperature at the surface of the sphere equals 50. Next problem. So the next problem, here a rectangular box open at the top is to have a volume of 32 cubic feet. Then find its dimensions if the total surface area is minimum. So you have to find the minimum total surface area of the rectangular box. So use the condition. Here the condition is the box is open at the top. So first it is 3 variables. Since they given the volume, you have to consider the x, y and z. So I take the first one. Let x, y and z be the length, breadth and height or edges of the rectangular box. Let V be its volume. You have to find the surface area. So I taken the S be its surface area. Next, since the volume formula, you know the volume formula V equals xyz. The given the volume is 32 cubic feet. So V equals xyz equals 32. Next, consider the total surface area is, you know the S equals, it is rectangle, since it is rectangular box, it is 2 times of xy plus yz plus zx. But in the problem, they given the rectangular box open at the top. So just consider that since the box is open at the top, then the corresponding surface area is 2 times of xy plus yz plus zx. You have to take the subtraction with any of the axes, either xy, yz or zx. I take the first one minus xy. So this implies the surface S equals 2xy minus xy, you will get the xy plus 2yz plus 2zx. This is the surface. Next, we have to find the x, y, z values such that the S is minimum subject to the condition x, y, z equals 32. Write this step by step. First you form the function using the condition. Next differentiate with respect to x, y, z. Then equate all the values of lambda. You will get the stationary values. Then substitute the stationary value to the given surface. You will get the minimum surface area. First, I construct the function f equals xy plus 2yz plus 2zx plus lambda times of the condition they given xyz is 32. So excluding 32 you consider. Since the differentiation of constant is 0, so no need to consider 32, just write xyz. Then form fx equals 0, fy equals 0 and the last one fz equals 0. So using the first one, you have to differentiate with respect to x, you will get the y. Second term, the differentiation is 0. Third one, the differentiation of x is 1 plus lambda times of the differentiation of x is 1, you will get the yz equals 0. This is the first part. So lambda, you can also write the lambda minus y plus 2z divided by yz. Similarly, the second part, with respect to y, you have to take the differentiation. X plus, here the y differentiation 1, you will get the 2z. Here the differentiation of z and x is 0 plus lambda times of, with respect to y, you will get the xz equals 0. This is the second part. So using this, you can write the lambda equals minus x plus 2z divided by xz. Similarly, the last part with respect to z, first part is 0, 2y plus 2x plus lambda times of xy equals 0. This implies lambda equals minus 2 times of x plus y divided by xy. Then equate all the values of lambda, you will get the points. So the first one, minus y plus 2z divided by yz. Second term, minus x plus 2z divided by xz. Last one, minus 2 times of x plus y divided by xy. Next, equate these two, first and second, then equate the second and the last one, and also first and last terms. So the first one, by cancelling this negative sign, equate these two. So y plus 2z divided by yz equals x plus 2z divided by xz. Here z and z cancel. Then cross multiply the term. You will get the xy, this cross multiplication, 2zx equals here the xy plus 2zy. xy and xy get cancelled. Same 2z also get cancelled. You will get x equals y. So in the condition you can substitute y equal to x. Similarly, equate the second and the last one. X plus 2z divided by xz, it is 2 times of x plus y divided by xy. Then cancel the x term, cross multiply, xy plus 2yz equals, so you have the 2 times 2xz plus 2yz. Next, 2yz and 2yz get cancelled, x and x term get cancelled. You can write y equals 2z. And you got the y equal to x, substitute y equal to x equals 2z, or you can also write z equal x divided by 2. Then substitute these x, y and z to the given condition, you will get the stationary values. Therefore, substitute x, y and z in the given condition, v equals x, y, z. X you retain as it is, y you replace by x, z is x divided by 2. They given this as 32. So multiply this, you will get the x cube equals, cross multiply, you will get the 64. This implies take the cube root on both the sides, you will get the x equals 4. Since x equals 4, y is also equals 4 and z is x divided by 2. So we will get the z equals 4 by 2, it is 2. And here they asked to find its dimensions if the total surface area is minimum. Hence, the dimensions of the rectangular box is the first one 4, x is 4, y equal to 4, z equal to 2. Hence, the dimensions of the rectangular box is x is 4, y is 4 and z equal to 2 such that S is presumed to be minimum. My next topic is Jacobians. Jacobians, first I tell you the definition. Jacobians, if u and v are functions of x and y, then Jacobian j of these functions are given by, this is the Jacobian symbol, J equals delta of u comma v. U, v are the two functions depending on the two variables x and y. So del uv divided by del xy equals determinant of first term is partial derivative u with respect to x, same u with respect to y, v with respect to x, v with respect to y. This is the formula. This is with respect to the two variables. If you have the three variables, that is u, v, w depends on x, y and z, you have to construct the third order determinant, that is 3 cross 3. So depending on the variables, you have to construct the determinant. If it is two variables, then you consider the 2 cross 2. 3 variables, then 3 cross 3 third order determinants. So directly we will go to the problems. So the first problem, if x equals r cos theta and y equals r sin theta, then you have to find the Jacobian j. First to see the variables. Here x and y depends on r and theta. So you have to write the variable, that is you have to write the Jacobian j equals del xy denominator del r comma theta. Here xy depends on r and theta. So you have to, since you have the two variables, you construct the 2 cross 2 determinant del x with respect to r and the del x with respect to theta. Similarly, the del y with respect to r and the del y with respect to theta. So the first differentiation, since it is a partial derivative, the x with respect to r, you have to keep the theta constant. So r differentiation is 1, so we will get the cos theta for the first term. Similarly, x with respect to theta, so cos theta differentiation is minus sin theta, keep r as it is. Similarly, y with respect to r, it is sin theta, y with respect to theta, it is r cos theta. Then expand the determinant, you will get the answer. So j equals, cross multiply this, r cos square theta. Since you have the negative, you will get the minus of minus r sin square theta. So simplify this, r you keep it outside, cos square theta plus sin square theta equals, since the cos square and sin square equal to 1, you will get j equals r. This is the answer. Second problem. Here the given x equals r cos theta, y equals r sin theta, same as previous one. But the given z also, z equals z, then you have to find the Jacobian. Since here you have, since in this problem, we are using the three variables, you have to write the Jacobian with respect to three variables. So write the solution j equals, since you have the three variables x, y, z depends on r, theta and z. You have to construct the 3 cross 3 determinant. So this equals, first to write the formula, the first one x with respect to r, x with respect to theta, x with respect to z. Similarly, second one y with respect to r, y with respect to theta, y with respect to z. Last one z with respect to r, z with respect to theta and z with respect to z. Next, differentiate one by one. The first one, x with respect to r, the same as previous problem, we will get the cos theta. With respect to theta, minus r sin theta. With respect to z, since you don't have the z term, the differentiation 0. Similarly, next one, y with respect to r, it is sin theta. Y with respect to theta is r cos theta. Y with respect to z is 0. Similarly, last one, z with respect to r is 0. With respect to theta is 0. With respect to z, z you have, so the differentiation is 1. expand the determinant plus, minus and plus. So the first term cos theta, delete the corresponding row and column, take the determinant for the remaining term, you will get the cos theta minus 0. Similarly, second part, you have the negative and negative will get the positive sign. Next, r sin theta, delete this row and this column, take the determinant for the remaining term, you will get the sin theta minus 0. Last one, you have the 0, so you will not get any terms. So this implies you will get the r cos square theta and r sin square theta. By keeping r outside, it is cos square plus sin square theta. The cos square and sin square theta is 1. You will get r is a Jacobian. Next problem, third one. If u equals, they given the u, v and z terms, u, v and z depends on x, y and z, then you have to prove that j equals 4. So as usual, first write u, v, w depends on x, y and z, then write the determinant of order 3, then differentiate, expand, you will get the answer. So the first one, j equals, here u, v and w depends on x, y and z. Next you write the 3 cross 3 determinant. First u with respect to x, u with respect to y, u with respect to z. This is the first row. Similarly, v with respect to x, v with respect to y and v with respect to z. Second row, w with respect to x, w with respect to y and w with respect to z. This is the third row. Then differentiate and expand, you will get the answer. So the first one, u with respect to x, since x is in the denominator, the differentiation of 1 by x you have to consider. So differentiation of 1 by x is minus 1 by x square. Next, with respect to y, y differentiation is 1. With respect to z, z differentiation is 1. Similarly, v with respect to x, z divided by y. With respect to y, y is in denominator, minus zx divided by y square. With respect to z, the differentiation is 1. Similarly, w with respect to x, it is y divided by z. With respect to y, x by z. With respect to z, z is in denominator, minus xy divided by z square. Next, expand this, you will get the answer. So the first one, you consider plus, minus and plus sign while expanding. First term is minus yz divided by x square. Delete this row and column, take the determinant. So the first term is minus zx divided by y square into minus xy divided by z square. I take the bracket. Second term, cross multiply this, minus x by y, x divided by z. Similarly, second part, it is minus z divided by x. Delete this row and column, take the determinant. So just cross multiply this, minus xyz divided by yz square, minus these two terms, xy divided by yz. And the last term, it is plus y divided by x. Delete this row and column, take the determinant. So it is xz divided by yz. Minus of this, you will get the plus sign. It is xyz, denominator, zy square. Now we cancel the term. Here the negative and negative become positive. Z get cancelled one time, y also get cancelled. Similarly, in this part, z get cancelled and also y. Here z and z, z and y. Write the remaining terms. So the first part, it is minus yz divided by x square. Here I will get x square divided by yz. minus x square divided by yz. So the answer is 0. Similarly, second term, minus z divided by x. Here you will get the minus x by z, minus x by z. Write this term as minus 2x divided by z. And the last term, plus y divided by x. Here x by y and x by y you have the 2 times, 2x divided by y. So cancel y and x, here z and x. So we will get minus and minus, you will get the plus sign. Here also the plus 2. So the answer is 4. This implies the Jacobian equals 4. This is the answer. So next problem, here they given x equals u of 1 minus v and v equals and y equals u into v. Then you have to find the Jacobian and also prove that j dot j dash equals 1. So I will first find the Jacobian, next I will come to j dash. So the first one, the solution, j equals, here x and y depends on u and v. So you have to write the determinant x with respect to u, x with respect to v, 2 cross 2 determinant, y with respect to u and the y with respect to v. So x with respect to u, the differentiation, since you have the product, the differentiation of u is 1, you will get the 1 minus v as it is. Next term, with respect to v, keep the u term as it is, the 1 differentiation 0, the v differentiation is 1. Similarly, y with respect to u, you will get v, with respect to v, you will get u. Then simplify this by cross multiplying u minus u into v, you will get the minus uv. You have the negative sign minus u, cross multiply, you will get the plus uv. So we will get the j equals, by cancelling these two, you will get j equals u. Next they asked to find the j dot j dash. For j equals del of xy, del of uv, j dash means you have to interchange these two. This numerator and denominator will interchange. So in the numerator we will get del uv, denominator del x comma y. Next express uv in terms of x and y, then you have to take the differentiation, you will get the j dash. So write this step by step. So the next part, I consider the j dash equals del uv divided by del xy. That is, you have to express uv in terms of x and y, but they given x in terms of uv. First you multiply x equals u minus uv. So multiply u within a bracket. Next the given y equals u into v. Here you have the u in v, so substitute y, x equals u minus y. So you can write this term u equals x plus y and v equals y divided by u already got x plus y, x plus y. So first to express uv in terms of x and y, then you apply the differentiation. So I just write the j dash equals, this is the formula, you write the 2 cross 2, it is u with respect to x, u with respect to y, v with respect to x and v with respect to y. Then expand, then take the differentiation, u with respect to x, you will get the 1, 1 plus 0. Next u with respect to y is also 1. V with respect to x, x is in the denominator. So you will get the minus y divided by x plus y whole square. Then x plus y differentiation 1 plus 0. Similarly with respect to y, this part, the y is also in the denominator. You have to apply the quotient rule, del v divided by del y. It is denominator square. Write the denominator, numerator differentiation is 1. Minus numerator, denominator differentiation 0 plus 1. So minus and plus y get cancelled. you will get this answer x divided by x plus y whole square. You substitute here x divided by x plus y whole square. So on expanding this, you will get x divided by x plus y whole square, cross multiply. You already have the negative sign. So plus y divided by x plus y whole square. So this part, you will get the x plus y is in numerator, x plus y whole square. Cancel these two, you will get 1 by x plus y. But x plus y, you have taken it as u, you will get 1 by u. Next, you have to prove j dot j dash equal to 1. So I'll write it here. Consider j dot j dash. This equals, the j you got the answer as u. J dot is 1 by u. By cancelling these two, you will get the answer as 1. This is the proof. Next problem. In the next problem, here the given x plus y plus z is u, v and w. But they asked to find the Jacobian x, y, z in terms of u, v and w. So, first you rearrange the given equations to express x, y and z in terms of u, v and w. Let's say that. So, the solution of this, here they given x plus y plus z equals z equals u and y plus z equals v, z equals u, v, w. So for y plus z, you substitute v, x plus y plus z, put v equals u. So x can be expressed in terms of u and v. This is the first part. Similarly, the second one, y equals v minus z. Z can be written as u, v and w. V minus u, v and w. This is z. Z is already in terms of u, v, w. So no need to rearrange. Next, write the Jacobian j equals. Here the x, y, z depends on u, v and w. Next, you expand this. First, you write the formula x with respect to u, x with respect to v, and x with respect to w. Similarly, y with respect to u, y with respect to v, and y with respect to w. Next, z with respect to u, z with respect to v, and z with respect to w. First you take the differentiation, then expand, you will get the answer. First one, x with respect to u. First one, x with respect to u. You will get the 1 minus 0. Next, with respect to v, 0 minus 1. With respect to z, the differentiation 0. Similarly, v with respect to u, 0 minus vw. With respect to v, it is 1 minus uw. With respect to w, it is 0 minus uv. The last one, z with respect to u, you will get vw. With respect to v, uw. With respect to w, u into v. Then expand this, you will get the answer minus plus. So the first term, 1 times of, delete this row and column, take the determinant on cross multiply, uv minus, here u square vw, here you have the negative sign plus, cross multiply this, u square vw. This is the first part. Similarly, second term, you have the negative sign, you will get the plus 1, delete this row and column, cross multiply, minus u v square w, here this one, plus u square vw. The last term is 0, so no need to take the determinant, no need to take the term. So next, these two get cancelled and these two get cancelled. You will get j equals u into v. This is the Jacobian.